First of all, do you know what collinear means? They're all in a straight line, and we got three-dimensional vectors, so we got points in three-dimensional space that all line up nicely in a straight line, or at least that's what we're supposed to show. How do we show that? How could we show, this is what we want to prove, what are different ways to prove that those are in a straight line and not in a bendy line? What's one idea? We could what? Draw the vectors. Like so. So those are my three-dimensional vectors, A to B. And how does that going to help me show that they are in a straight line? What can I do? Because if I draw the vectors either way, A to B, B to C, that gets me to A to C anyways. So we could look at A to C, right? We could get a vector for A to C. And then you're going to, how would you find out if B is on that line or not? Okay, we could find the three-dimensional slope and see if this slope was the same as this slope. Then they would all have to be the same. And you would have, we'd have to define a new definition for slope, because our slope in 2 dimensions is rise over run, right? What are we going to call it in 3 dimensions? Rise over run over hop? And it has to start with R, right? Because your rise and your run have to do with your x and your y, right? Because you'll have your rise, your run, and then you'll have something else because you have that extra dimension. Any good R words that could go with that? Rise, run. I'm not thinking of any good R words right now. Roll, maybe? Rise, run, and roll? Yeah, okay. So you got your Z could be your rise now. Your X could be your run, and your Y your roll. I'm not sure. Well, we've written it as rise is the X, run is the, so then we'd have to redefine them. Anyways, we could look at that. That's one way of figuring out whether they're collinear. I think it would be nice if we wrote these as column vectors. So 2, -1, and 1 for A. For B, we're going to have 6, 11, and -7. And for C, we're going to have, oh, that was C. So 6, 11, and -7. And for B, we're going to have 3, 2, and -1. A to B is a vector. How would I write vector AB? Well, you'd have to go -A and then go to B. Does that make sense? That A to B as a vector will be -A, 2, -1, and 1, plus B, 3, 2, and -1. And A to B as a vector will come out as 1, 3, negative 2. That's the direction. It's going 1 in the x direction, so that's our rise. No, that's our, we have to change these words. Rise over run over roll. If we're doing the x first, run, do we call the, what did we figure out? Do you want to keep run and rise with the x and the y? And then you just roll in a vertical direction? Run, rise, roll? I don't know. It's kind of nice to have rise, run, roll, but then it doesn't match up with the... So we've got a run of 1, a rise of 3, and then a roll. I guess it goes downhill here, negative 2. Now if we go from B to C, well, that vector would be negative B. So we'd start with negative 3, 2, and negative 1, and then we add C to it, which is 6, 11, and negative 7. And we get 3, 9, negative 6. Those numbers are different, though. How do we know that they have the same 3-dimensional slope? We could divide them by 3. And then we notice that we just have a multiple of what we had before. And we saw that in 2 dimensions as well, right? In 2 dimensions, if you had a slope of 3 over 2 and your other line had a slope of 6 over 4, and we say, oh, the slopes are different. Well, no, they're just multiples of each other. It's because B to C is a longer length than what it is from A to B. So that's one way to show that they're collinear. To notice that the same direction vector is happening. We're going in the same direction. So if you're going in the same direction from A to B, and then you stay in the same direction from B to C, you just go 3 times longer, then you would know that from A to B to C are all on the same line. Another way that you could show that things are on the same line is looking at distances. Does it make sense that if the distance from A to B plus the distance from B to C is equal to the distance from A to C, then they have to be in a straight line? Can you see in my second diagram here with the red arrow that going from A to C is shorter than going from A to B and then B to C? So we could use our distances, and we know that, right? We could figure out the distance from A to B. We could figure out the distance from B to C, and then figure out the distance from A to C. And if A to B plus B to C, if that distance is equal to the distance from A to C, then we would know that it's equal. Yes?
But you have also like a unit vector.
And then,
Because then the unit vector is the same, and would mean it's the same vector.
well, it would be very similar. If we found the unit vectors for each of these, that would be the same kind of idea as here, showing that they're in the same direction. The unit vector just has a length of 1, but they would both of these would have the same unit vector, right? Because this one you'd have to divide it by its length. But if you're going to find the unit vector for each of them, then you're going to have to find their lengths anyways. And so I think the slope idea, showing that they go in the same direction, is the quickest way. If we found out the length of A to B, you're going to get the square root of 1 plus 9 plus 4, which is the square root of 14. And B to C, you're going to just get the square root of 9 plus 81 plus 36, which is square root of 126. And 126 divides nicely by 9, which gives you 3 root 14, which kind of makes sense because this one is 3 times longer than that one. And then if we found out what vector a to c is, so which we haven't done yet, vector a to c would be negative a, which was 2, negative 1, plus vector c, 6, 11, negative 7. We're going to get 4, 12, negative 8, which happens to be the same slope because we're going to get 1, 3, negative 2 there. And if we figure out its length, 16 plus 144 plus 64, we're going to get the square root of 224. Yeah, which is 4 root 14. And if you look at AB plus BC, it's equal to AC. And then that would also show that all 3 of those have to be in a straight line. Yes?